Good morning, ladies and gentlemen. Welcome to IVS 2022 warm-up, the online technical conference preparing to IVS first edition. First of all, let me thank you all for coming here today. Let me introduce myself. I'm Virginia, one of VALVEcampus organizers. The topic of today's presentation is the opportunities for valve diagnostics with Ethernet in the field on positioner. The last minute of presentation will be the question and answer part. Please write your question in the chat box. It's now my pleasure to present Melanie, Product Management at Samson Group. Thank you so much and have a good presentation. Melanie, you can start.
Hello and a warm welcome to the audience. It is my great pleasure today to talk to you about the opportunities for valve positioners with integrated valve diagnostics based on the upcoming Ethernet APL technology, and with this regard to give you some insights into current developments within the process industry and at Samson. My name is Melanie and I'm head of the Product Management Department Digital Solutions at Samson. I'm based in the headquarters of Samson in Frankfurt, Germany, and in daily business I focus on digital products and connectivity solutions for field devices such as positioners. So for those who don't know Samson yet, I would like to give a short overview of the company. So Samson was founded in 1907 and we are active in the wide field of the process industry for more than 114 years now. You can see some pictures of our headquarters in Frankfurt on the pictures on the slide. So we have the administration part as well as R&D and also the main production site here. The turnover in 2019 was more than 660 million euros. We have more than 4,500 employees in more than 40 countries and more than 200 locations worldwide, with 17 production sites in total. Samson is still a family-owned company with about 60 shareholders. Actually, Samson is active worldwide, and you can find our products and applications wherever fluids are in flow. So our core markets are the chemical and petrochemical industry, food and beverages, industrial gases, district energy, and pharma and biotechnology. But we are also very active in oil and gases, in marine equipment, in water, for example, and also in hydrogen value chains. For the process industry, we deliver a very broad product portfolio consisting of different kinds of valves, actuators, and valve accessories like positioners, for example. Additionally, we have enlarged our portfolio by state-of-the-art digital services in the past few years, which complements the traditional component business with enhanced cloud services. This is our so-called SAM digital portfolio with solutions for different markets and products, like SAM valve management for the process industry and for our valves with positioners, SAM district energy for the district heating and cooling, or also SAMguard as an overall approach for process plants. Digital solutions are actually a big part of the overall Samson vision, which is to meet our customers' needs with high quality products, but also with modular systems, asset management and services, and cognitive solutions around them. So, talking about state-of-the-art digital services for the process industry and diagnostics for field devices, the possibilities pretty much depend on field device data, which means collecting data on the one hand, but on the other hand to also make the data usable. Now, the current situation can be described very well with the help of the automation pyramid, which is, I guess, very well known. The automation pyramid describes the architecture of process plants in a very clear way. So, as we can see on this slide, existing process plants are basically divided into different levels. So, starting from the ERP level on top, and then going down to the plant level, the process level with a distributed control system, the control level with all the gateways and controllers, and finally the field level with all the field devices that are installed in the plant, like control valves and sensors. The main characteristics are now that we have a vertical communication. We have this fixed structure divided in functional levels, and this results actually in finally restricted topologies with also proprietary technologies for communication, for example. So finally, the main problem is currently that the communication of data is very much restricted by this inflexible architecture. Now, in order to get more flexible structures, current developments tend to soften the boundaries of the automation pyramid. And this means that some characteristics still remain in place, so we still have vertical communication. We still have a fixed structure divided in functional levels, just coming from the history of the past decades. But what is changing now is that we will have more and more standardized technologies, for example with Ethernet APL and also OPC UA. And therefore we get way more open topologies as well. So the next step to a fully open architecture in the future will then be the transformation of the vertical communication and the fixed structures. And exactly this is shown on this slide with regard to the future of process automation. So the ultimate key is that assets will be able to communicate among each other. So there will be both vertical and horizontal communication, which will lead to fully open structures and topologies. One of the big advantages is that overall cloud services will also enable real predictive maintenance concepts for entire plants, and the analytics and optimization of entire processes will therefore become reality. So such open architectures are really crucial for systematically gathering field data and for making this data usable for monitoring and also optimization purposes. Well, as already mentioned, the first step to more open process automation will already be possible based on standards that are currently gaining more and more momentum, like OPC UA as a standard protocol for the process industry, and Ethernet APL as a brand new Ethernet communication standard. Okay, so now I have already mentioned the Ethernet APL technology several times. Therefore, I would like to take the opportunity to tell you something more about this technology, about the background, and also the advantages for positioners, of course. So APL itself stands for Advanced Physical Layer, which means that it is just the physical layer standard that makes it possible to bring Ethernet communication down to the field level and to use Ethernet-based protocols such as Profinet, Ethernet IP, or Hard IP for the communication on top. Therefore, also the organizations that are listed here, Fitcom Group, ODVA, and PI, are pretty much driving this technology next to the actual member companies, so the suppliers and manufacturers, among also which Samson participates. And you can see that with the further member companies that are listed here, like Anderson-Hauser, Phoenix Contact, Rockwell, Siemens, and so on. It is really a powerful group within the process industry that is really driving this technology. So this group has formed the standard of Ethernet APL, which is now a dedicated Ethernet solution for the process industry with common two-wire installation for field devices, which is of course very important for the process industry, based on IEEE and IEC standards. Ethernet APL is in general meant to importantly simplify the planning, the installation, the commissioning, and the maintenance of field devices and automation. On this slide, you can see an example of an Ethernet APL topology. So the most important benefit is, of course, that the installation, which you can see in explosion protected areas, is possible based on two-wire installation with the help of the APL field switches. And as you can see, trunk lengths of up to 1000 meters and spur lengths of up to 200 meters are possible. So as a maximum range, 1200 meters, which is a very long range. And this, of course, with a very high communication speed, thanks to the Ethernet communication, which is in the first step up to 10 megabit per second. And this high-speed Ethernet can then be used for operation, engineering, and for asset management activities, but also, and which is very important, for other applications, such as cloud services, for example. So that means that the direct connection to upper-level asset management really becomes a reality based on Ethernet APL. But what are now the real advantages for positioners? Well, generally it is mainly about an increased efficiency in the device handling, you can say. The fast communication speed makes it possible to get really quick access to the devices and therefore to realize a very fast remote configuration and also troubleshooting. The direct connection to asset management systems also helps in implementing predictive maintenance concepts and of course enable way more user-friendly use of device diagnostics in terms of dashboards or also a better visualization of device analytics. So Samson has actually a very long history in positioner technology, with the first positioner already launched in 1957. Since then, we were always able to deliver state-of-the-art devices, like the first digital positioner in 1995, or the first modular positioner in just 2016. Therefore, we can also offer a broad portfolio of different versions, like for example with the common communication protocols, HART, Profibus PA or Foundation Fieldbus, but also with XD solutions, with basic solutions and so on. In total, there are already more than 1 million Samson positioners working properly in the field. So as just mentioned, one of our product highlights within the portfolio is the Trovis 3793 as the first modular positioner. It offers a protected non-contact travel sensing, which means that the travel sensing system is located inside the housing. Additionally, it includes a modular and flexible concept for options, so both pneumatic and electric options that can easily be retrofitted and added during operation. It has a footprint of our proven 3730 series, so the same mounting kits can be used. But it has 2 air outlets, which makes it possible to use the device also for double-acting actuators. Then furthermore, there is an integrated plain text display that also indicates symbols like the Namur coin and state. and the positioner has a very high air capacity up to kVs 0.7. And due to these advantages, it is also the Travis 3793 platform that we will equip with communication possibilities based on the Ethernet APL technology, such as Profinet or Ethernet IP in the future. It will then combine all the advantages of the positioner hardware features with all the advantages that Ethernet APL offers, like the communication speed of 10 megabit per second that will be very useful in order to make the integrated valve diagnostics really usable for our customers. It will also offer a user-friendly access to integration files and also to any other device-related documentation and the device data itself. And of course, the technology that will enable the connection to upper-level asset management systems through OPC UA, which will also make it possible to realize smart predictive maintenance concepts. And finally, an easier device access will also be possible using, for example, a web server. So talking about the importance to quickly have access to device data, the question is now, which data are we actually talking about? During operation, it will first of all be diagnostic data that gives a big value to the user. So the positioner integrated Samson Valve Diagnostics Expert Plus continuously monitors the valve stroke, the actuator force, and the air supply if pressure sensors are integrated, and that makes it possible for the positioner to detect deposits, abrasion, or also increased friction, which can then be visualized through histograms, through graphs or status messages and performance figures. And the real advantage of Samson Diagnostics is also that it is always fully integrated in the positioner and always available through all possible access possibilities. So for example, the DCS or also on-site directly at the device. Now, this diagnostic data can be made way more usable through Ethernet APL, as there will also be the possibility of a direct connection to upper-level asset management and monitoring systems. And actually, Samson offers an own solution, which is called Sam Valve Management, and which has just been released some weeks ago. So if you're interested, I can recommend to you to watch the short and actually very nice product video that you can find under the QR code on this slide on YouTube. However, for the moment, I would like to give a short overview of the solution. So for Sam Valve Management, we're very glad to benefit from the Samson experience in valve technology of more than 100 years. We combine this technology experience with enhanced diagnostic algorithms and all the advantages that a state-of-the-art web-based platform offers nowadays in order to offer our customers a smart monitoring and valve management solution for the valves that are installed in process plants. Some of the product highlights are a plant-wide overview of all the valves that are integrated, smart enhanced valve diagnostics through the platform. It offers also plant-wide and also detailed valve reports and clear recommendations for action in case that maintenance is needed for a valve. Additionally, we offer also special service packages to our customers. So finally, the solution is a powerful overall package consisting of hardware in terms of our proven Samson positioners and a cloud-based solution. So finally, I would like to summarize the opportunities for positioners with integrated valve diagnostics based on Ethernet APL. So we have actually talked about a quick NIP-based access to devices, about the quick access to all device-related data like integration files and documentation, or really the data that is stored inside the positioner, about the direct connection to upper-level asset management systems, and therefore the user-friendly use of diagnostics. We have talked about the realization of predictive diagnostic concepts and the identification of valves that need maintenance. And this all will help to realize an easy device handling, to increase the asset availability, and also to make device configuration and maintenance a lot more efficient, and to finally increase the planned efficiency and uptime. So now I've come to the end of my presentation, so thank you very much for your interest, and let's start the Q&A session.
Melanie, modern positioner already offer diagnostic capability and even support fast fieldbus communication. So, what is the great innovation of Ethernet APR?
Yes, this is actually a very good question. So also Samson positioners offer integrated diagnostics and feedback communication for more than 15 years now. However, most users have never really worked with the diagnostics according to our experience. As for hard devices, it simply takes too much time to read out the data over the hard protocol. Now, Feedbus is of course a lot quicker compared to hard, so we're talking about 31.25 kilobit per second compared to 1.2 kilobit per second, which is about 26 times faster. But finally, compared to modern Ethernet communication, it is still really slow. Additionally, the interpretation of the data has so far mainly been something for experts. And this is now exactly how Ethernet APL takes us to the next level. So not only the communication speed, and with this regard, the comfort to get diagnostic data improves, but we also get better opportunities to analyze and visualize this data, for example, through the direct connection to asset management systems with a user-centered approach.
The second question is, how can upper-level asset management system be helpful for plant operators if a positioner already supports valve diagnostic?
So it is right, smart positioners already offer diagnostic information. So for example, for Samson positioners, there are on-site diagnostics via the display that indicate possible failures. Then over the DCS, there is even the possibility to show diagrams, trends, and other visualizations that can be used for predictive maintenance. However, upper-level management systems even go further and have all the possibilities that state-of-the-art platforms offer nowadays, like enhanced algorithms and services. So for example, if there is a very slow trend of a zero-point shifting in the valve, this could be detected with an asset management system like Valve Management from Samson, also with considering user-specific limits for alarms and in combination with an automatic alarm management.
Melanie, what about the time frame for Ethernet APL? When will the first device be available?
Yes, this is surely a very interesting question for the entire audience, so thank you for asking this. Well, the official technology launch is scheduled for mid-2021, so that the first devices can be expected until the end of 2021, among which also the first Samsung Profinet positioner will be. And then a bigger variety of Ethernet APL devices will probably be available in 2022.
Melanie, your next question is, will it be possible to integrate a Samsung Ethernet APL positioner into an X-Time plant?
Well, first of all, it is not possible to integrate Ethernet APL field devices into existing infrastructures based on 4020 milliamps or fieldbus installations. There is always the entire infrastructure needed with APL field switches. However, in case of existing fieldbus installations, an easy migration is possible in terms of reusing the existing fieldbus cable type A, which can be used for Ethernet APL as well. But generally, the entire plant infrastructure needs to be Ethernet APL compatible.
Thank you, Melanie, for your guide presentation. The time is over.
So thank you very much and enjoy the further conference.
I wish you all a very nice day. Bye-bye.